All right. So, if you're seeing this, yes sir, no sir, you can type in the chat. If you're
Yes,
seeing this,
sir. See.
all right, good. Um, yeah. So let me get my pen here and fix that. So we won't be having a long class today. All right. Won't be having a long class today,
Excuse me,
but
sir.
we'll go over some important details after this.
Mr. Treasure, sir.
Yes, sir. I hear a question.
Yes. Mr. Williams.
Yeah, go ahead.
Are we going to yes, sir.
Go again.
Are we going to get
Are we going to get what?
are we going to get a test?
A test.
Yeah.
For today.
No. For us.
Matak overall, sir.
Oh yeah, of course. The test would I well right now I'm awaiting instructions from my supervisor. I'm sorry, Mr. Noble. I'm going to have to mute you. Right, yeah. So I'm awaiting instructions from my supervisor. No, but you will of course get a test for your final in in December, right? But as it relates to a midterm test, I don't see a midterm test. I mostly see you doing labs, focusing mostly on labs, right? And I don't even want you to if we can just skip the September, I'll try ask them to skip the the December exam and just focus on finishing the syllabus because that's the most important thing right now. Maybe that won't work, maybe it will work, right? But I see a test in the future, but mostly we're going to focus on labs. That's the most important thing right now. Soon as you get the chance to focus on labs. So all the content that we're doing now is lab based. You have everything that you're gonna need when you actually take on your labs, right? Any more questions before we begin? All right. All right, so let's move on. Um, we'll recap some of the important things for today. Um, so we'll just go over this question. Trolley A with a mass 300 grams and a velocity 9 meters per second. Alright, collides with a stationary trolley B, and both trolleys move together. So find the momentum of trolley A before the collision. Right. So we did that yesterday. Um, we converted 300 grams to 3 kilograms, so 0.3 kilograms, right? And then we took that 0.3 kilograms and we multiplied it by our 9 meters per second, which would be our which which should be our momentum. So we got that final momentum, right? And we'll go to the units, of course, in a few minutes, right? But we want to make sure we get this, right? We'll go to the units because, of course, in physics, everything comes with units, right? And we can't just put 2.7 because what would that be saying? Are we saying 2.7 bananas, 2.7 monkeys, right? We're saying 2.7 something. All right, we'll move on to the second part of the question, right? So we found out the momentum of the of trolley A, which would be our trolley A, which we said was our Lamborghini, right?
Yeah.
Our Lambo. right? Alright, so now we want to find out the velocity of both trolleys after the collision. Alright, this is very important. The first instance, look up here for a second. Right, the first instance, okay. The first instance is that trolley A is moving towards trolley B, and we said that trolley B is stationary, right? Trolley B is stationary. In this case, it's not moving. What would happen afterwards? What will happen after the collision? What is happening here?
Oh,
It transfers the energy or the force or whatever.
Right. So the momentum, right? It's true because of the force of this. It transfers the momentum from A to B. Are A and B apart or are they together?
Together right now.
Yeah, so after the collision, they are now together. They're moving together. So we have trolley A, we have trolley B, and trolley A is coming with a force. It's going to take trolley B with it, right? And it's going to move across, right? So that's very important to note. And moving forward, no, do trolley in after the collision. So this is after the collision. After. So does trolley A and B have a separate velocity or do they have the same velocity?
Separate. Separate.
Separate? Try again.
The action would be same.
Yeah, the velocity will be the same. Why? Because they are moving together, right?
Oh.
Yeah, they're moving together. Right, and we can look on that for a second, right? We can just pause here and look on that for a second. Let's just test out what I just said, just to ensure that I'm not telling you foolishness. Let's bring it up. So we have we changed, this was first in elastic, right? Elastic meaning as they collide, what happens? They spread, right? They spread. Once they collide, they spread. Now, if they stick together, that is called inelastic, right? That is called inelastic. So we change our inelasticity to one to fully inelastic, and we get more data here. This is just doing this quickly, right? And we have our red object here and our green object here, right? And we look at we put the velocity at of two. No, this was stationary, right? So this is trolley B and this is trolley A, right? And now I'll increase the mass of this, and I'll kind of decrease the mass of this, right, to 1. And we play it now, right? So it looks a little better. Let's play it now, right? So before the collision, look at the velocities. Look at the velocity for trolley. What's its velocity for trolley? For number 1.
1, sir.
Yeah, what's its velocity
1.
for trolley for the
0.
second?
0,
0.
sir.
So look at the collision now. All right. So after they collide, what is the velocity now?
All of them are moving in the same place.
Have
They
the
are
same
moving at the
motion.
same place and they are moving at the same.
And
Velocity.
They are moving at the same velocity. That's what they just want to just prove,
Mm.
right? And that is inelastic. We'll go into that in a few seconds, right? But for this question, I'll need your help in solving. So let's go back to our principle, our law of conservation of momentum. And somebody remembers what this says again? Remember what this says?
No, sir.
what do you mean?
Conservation of momentum, right? We spoke about this. What does conservation mean?
Sir, like a fifth something.
Like a what?
You know, like you can like a like you
Conserve.
can serve like
Conserve.
Yes, sir.
We come up with a word constant, right? Constant. It doesn't change, right?
Oh, yeah.
Right. Constant. Whenever we see conservation, it means that it's constant, right? For example, if we have a leakage in our pipe, we want the water to be conserved. We cover the leakage so that the water in the pipe remains constant or it doesn't change, right? So momentum simply mean law of conservation of momentum, right? We spoke about this yesterday. It means that momentum it stays constant after the collision. So the momentum before the collision is the same as the momentum after the collision, right? For both systems. So let's put that down. Whenever we're starting a collision question, you want to start out with initial momentum equal final momentum. All right, so I'm going to need your help now. So initial momentum, what should be over here? Let me start. M1. Then what's next?
V1.
V1 plus
M2.
M2 V2, right? Then now over here for the final momentum, what do we have?
M1 V1 construct. So,
M1 V1, right? And we have this tilde up here, right? To show that to show that it's the final momentum. So you can just use final velocity. So whenever we see this, right, it's called the final velocity or the final velocity, right? Whenever we see that tilde at the top, it's just used to represent the final velocity, right? And what do we have? Plus M2, right? M2,
well, yeah.
M2 V2,
V2.
right?
Yeah.
And the tilde at the top to show that it's the final velocity. No, what did we say again? The both trolleys move together, right? That was the case. So what does that mean again? What does that mean about the velocity?
They equal.
Right. So V1 and is equal to V2. Right? We call this whenever this is called prime. So it's called V prime. V prime. This thing at the top, the tilde at the top, it's called prime.
Yeah.
Or final velocity. You can use either one. Alright. So we say V1 and V2 is the same. So we can just put them as V. Big V. Right? Big V. So we come down here now and we replace M1 with a and replace V1 prime with a big V plus M2 and we place another big V, right? So um if we do mathematics, what can we do here? Somebody want to give it a try?
Group like
Right, we can group them.
oh,
I'm looking for another word.
Factor.
Uh, Factorize. Thank you. So how would we factorize this?
M
We would
M
have what's the same?
V, sir. Yes,
Go
yeah.
ahead.
plus M.
No, sir. I would M bracket V bracket M.
So
No?
V bracket.
M.
M.
Yeah.
No, sir, that's wrong.
It's wrong.
1 M.
M V M bracket 1.
V M.
Square that. M square that.
No.
What then, sir?
This is M. M2. This is
Okay.
yeah.
Right, sir.
So that'll be M1 plus
And plus M2. Yes, sir.
M2.
Bracket.
Right. So we bring this down. M1 V1 plus M2 V2. No, what do we want to find now? We want to find the velocity of both trolleys after the collision, right?
Yes, sir.
Velocity. So what would we, what we want to try and get rid of?
The M.
You want to try and get rid of the M on which side?
The A side,
Over
first,
here.
Charlie.
M1.
Want to get rid of this because we want this guy right here. This is what we want. We want to solve this velocity here. So what would you do next?
Times.
We will times what
Oh.
exactly? We would have times. No, we would not times. Try again. Give it a try again. Right? We want to get rid of this. So we are trying. No, we want this V here. So we'll try and get rid of this, right?
You go add them, sir.
No, because this is
See, plus,
V times M1 plus M2.
plus.
So
Sir,
we want to try and get rid of this. So what would we do?
sir,
Try and get rid of.
We're what?
M1, sir.
We divide
Divide
both sides by what?
M
M1.
M1 plus M.
Right, M1 plus M2.
Sir,
Mr.
M1 doesn't
Rodney.
apply to all again. That's why.
Mr. Rodney, thank you. M1 plus M2. So we divide both sides, and what happens? What happens to this here?
Cancel out, sir.
This cancels out. Simple algebra. So our final velocity V is equal to M1
V1.
V1 plus M2 V2 over M1 plus M2. All right, so somebody go ahead and calculate this now. We have everything that we need. Remember, what about the momentum for trolley B? What is the momentum for trolley B?
Right. The last one I did.
No, that was trolley A. This was trolley A, right? Trolley A
move.
is not moving, right? So what is the momentum?
0.
Right. So I appreciate that, right? 0. So we don't have to worry about this guy. So all we have to worry about now is M1 V1 over M1 plus M2. right? All right, so give this a try now. Yeah, give this a try. Plug in your mass times velocity and for one, and then you put in this and tell me what you get.
Sir.
Go ahead.
In the collision equations, the momentum for the trolley B would be always zero, sir.
It depends if trolley B is moving. In this case,
So that's
it explicitly states that it's stationary, right? So that means that what happens? What is the velocity if it's stationary?
sir.
What's
Zero,
the
sir.
Yeah, the velocity will be zero. If trolley B is not moving, the velocity would be zero. So let's just do it up here, right? Pay attention up here, just to show you. So this is the formula: rho times mv, and if v is equal to zero, then we have m, which they didn't even give us the mass, right? So if we times a number by zero, the answer will be
Zero.
right. So we're not focusing on the momentum for trolley B for this question. I'm just realizing that we're going to need M2 for down here, but it's not in the question.
Why must a trolley B?
Hmm?
Must the trolley B?
Yeah, let's say it is 100. It's not stated in the question. I don't know why. So MB mass of trolley M2 is 100 grams. So you do your conversions and submit it. Why is it not in here? Yeah, let's just say M2 is 100. We get an answer. We got an answer? What are we doing?
Sir,
Yeah, go ahead.
we go to the point of V1 and M1 and V1. Sir.
Right. We have the mass
Yeah, and
of V1 of as what? What is the mass of M1?
um 0.3, sir.
Yeah, 0.3 times what?
Times, I remember that.
Yeah.
Uh, Let me get 2.7 over 0.4.
Yeah, so 2.7 over 0.4. So what's the final answer?
2.7. 2.7.
Go again?
27 over 4. 6.25, sir.
6.25.
Yes, sir.
Let's check mine again.
6.75.
Right, 6.75. Right, so we'll just do that for the rest of the class. Right, so M1 is 0.3
Yes, sir.
times
Times 9.
over
0.3.
0.3 plus
And plus
0.1. This goes down to 2.7 over 0.4.
4.
Then this boils down to 6.75. Right? What's your unit again?
MS.
MS to the -1, right?
Yeah.
Yes, sir.
All right. So are we good?
Good, sir.
All right, we're good so far. Sorry. All right. This meeting is about to end. Let me just check something. I think we're finished for today. We're finished early for today. Keep. Let me just check something quickly. If I have anything else to cover.
And them. This is your come across paragraph.
Yes, sir.
It's the common class today. So essay.
Which
Yeah, man.
The
Thank you, man.
repository. Repository.
Thank you, man.
the article then.
Remember, she want activity.
No, not yet. Active.
Positive, yes.
We are through for today. Oh yes, yes. Oh, good thing I looked. Was a good thing I looked. All right. We didn't speak. We didn't talk about the units.
The unit, sir.
The unit for momentum. How could I forget that? Right. And also, so we'll go to the slide. After the slide, we are through. I think we're going to have to come back. Right. All right. So let's end this and then come back and we'll finish this. It won't take long. We just have one more slide left to complete. All right.
All right, sir.
Yeah, we're gonna end early today. All right. So just use the same link and join back. We'll start again at about 9:17 or 9:18. We give it 3 minutes to come back.
All right, sir.